Mark, station on 3. Howdy here. This is Doug. Doug, I got you 5 by 5.
We started maybe 15 years ago in this long line of experiments that have been going to space that are all small-scale fluids experiments that have really taught us a lot about managing fluids in space without any moving parts, without any electricity, just fluidics. Now we can apply research results that we've learned from doing experiments in space to actual space systems that actually require gravity to be gone for them to work. That's different. That's a new horizon, I would say.
Okay, Mark, ready on step 4.
This is an engineering demonstration of a wastewater purification system. So inside that foam, there are all these weird channels and different wetting foams in there, such that capillary forces wick the liquids out, opening the channels up. So it's a capillary solution to an engineering problem of managing brine and contaminated water streams.
Yeah, it sounds really, really interesting and frankly really cool. I can't wait to see what it does.
What you're going to do is you're going to open that little valve out of the drink bag, and you're going to prime the tube. Then you're going to squeeze that bag, the drink bag, and then kind of in about 15 seconds fill the entire foam with the contents of the bag.
The interior piece of that foam is highly wetting, so it wants to suck up that water. But then there are pieces on the outside that are hydrophobic, so it doesn't want the water to penetrate through. So how can we, mix that up? What are the issues? What does that look like? Because ultimately this piece of technology, even though it's so simple as a piece of foam, it can potentially do so many things.
If you watch the videos, you see it, you're going to think it's dull and what are these goofs doing? You're going to say that. But basically what it is it's a dyed liquid. It's actually red fruit punch that we use, which is a simulant for urine.
You like the backlight view?
Yeah, we're geeking out over that. It gives us the complete view. This whole thing is nice.
That's pretty cool.
So the purpose of this experiment is to see how well does the foam hold the liquid in microgravity, and if we completely agitate it and really put this piece of equipment through the ringer, how well does it bounce back? Honestly, the most surprising thing that's come out of it is how simple we can make this technology. Maybe the foam project is going to enable a backup system for the toilets, or maybe it's going to be a new wastewater processing system altogether, and that's just the future. It's just, it feels like anything is really possible.
We are very hopeful that our work, which started out in fundamental research and is turned more and more applied, could actually get to the point where it's delivering on equipment. Equipment that functions without moving parts, or a minimum of moving parts, without power, without noise. We'd love it to have a system that just works passively by its shape. And whether it's on the moon or in orbit around the moon or in way to Mars, we'd love to contribute in that way and in the way that makes others able to do that too. So by publishing the design laws, by the design experience, by the experiment experience, we'd love to do that too.
I think it's just cool. It's so simple and it's so cool.
Subscribe for more space.